Okay, welcome back. So if we look at this variable map, as I indicated, what we see is that it starts at 0, 0, 0, which is kind of no color, which is black, and it goes all the way up to 1, 1, 1. So instead of representing R, G, and B as a number between 1 and 256, it's representing it here as a number between 0 and 1. So if we wanted to say, instead of black and white, let's go back to color map. If we wanted to represent this in shades of red, we can adjust it so that we have just this red number and not the blue or the green. And so we can do that by adjusting this variable map. So say that everything in the second column we want to make equal to 0. And also in the third column, we want to make everything equal to 0. And then if we type in color map again, we'll have this red shade. So I want you to also try, say, doing that with blue or with green. So we can, instead of just loading this default image in Matlab Juror, we can also upload or load in different files like a TIFF or JPEG or BMP with this command imread, image read. If you use it for indexed images, which are what like we've already had, where the values in the image variable represent some rows of the color map, like a GIF, for example, then we load in X and map, where X is the data and map is the color map. So X becomes an M by N, rows and columns, matrix of color indices. Or we could use it to load in with just a single image, non-indexed images like JPEG files. And JPEG files are treated as an M by N by 3 matrix, where instead of an M by N with each item showing an index and a color map, here the third dimension represents the red, green, and blue of the image. So the first row and the first column of the image will have 3 dimensions, one for red, one for green, and one for blue. So we can go into the help for imread and see more information. So let's start today with this script that we're going to make called class demo. So let's say edit class demo.m. And let's create it. Yeah, so I have it up here with my image. So here's my script. And we're going to be working with some images on this website. So you can copy this website and go over to the website. And you see that there's both these 2 images here and a bunch of letters that you'll use for an assignment. So I want to save these images. So I can do it in a number of ways. The easiest is to right-click, Save Image. I've already saved it in this folder in my workspace. There's a GIF and there's also a JPEG. So I'm going to save both of them. And you can see here in Matlab I have both of those saved in that workspace, in that folder that I'm currently working in. You can even see previews of them down here when I click on them. So let's go over here to the slides, and as I said, go to this website and download this GIF and the JPEG of that Vision Lab logo. So we're going to start here loading in that GIF, the GIF file. So in here we'll type in X and map, and that's a lowercase x, so we'll say imread, and we'll say Vision Lab, and it's a GIF. And then we'll say image X, axis off, axis equal, so we present it as a picture. And then we'll have the user, when they run this, press a button. We'll have them cycle through a number of color maps that you can use to present this. And so we'll start off color map, which is the one that it loads when it loads the image up here. And I guess I should write up here, clear all, close all, CLC. And let's say we also want it to print in color map hot. So let's run all this first. We can run that. It closes everything. Here's our workspace. Then we can run this and see that it's created this variable, 400 by 400, and a color map as well. That's 256 rows. You can see all the items there. So we can use that color map to plot the image. Here's the image. We can make the axis equal. Then we'll have the user do this. So now it's going to wait and say press a button. And so we'll press space bar. And press enter, and it will change the color map to the color map map. And then when we do that again, it'll change the color map now to this color map hot. So we can change the color map that we're using to present this image. The image is all here in this variable, and the different color maps have different items in each row. Now let's try it with the JPEG image. So let's go back to our script here and copy all of this. And right here, we instead want the JPEG. So I'll run this clear, I'll close all, I'll load this in, but now see map has nothing in it, whereas X is 400 by 400 by 3. So if I were to say X, 1, 1, and all of those 3 dimensions, I get the red, green, and blue values for X at that pixel 1, 1. So I can now type in image X, axis off, axis equal, and then if I try to change the color map now, color map cool, nothing will happen. There is no color map here. It's using the actual red, green, and blue values from here in X. If I were to change it so that X, 1, 1 equals 1, then in theory I've changed just the top pixel to a different color here. Okay, so we can also write images to files. So for instance, we can make random masks of just random fuzz, black and white values, and write it to a file. We use this command where we have the matrix of the image. We could also have the name and the extension. And we can also do that with an indexed image by saving the color map here as well. So let's try this. So let's clear all, close all, CLC, and let's type in mask equals rand 400 by 400. There it is in the workspace, and we'll type in, and I'll delete these in my workspace for now just to show you how they appear. And we'll type in here, I am right mask, and we'll save it as mask.bmp, and it is a BMP. So now we've created this variable mask.bmp in our folder, and you can see the preview here shows that it is black and white and a random mask. So let's clear it out of our workspace, and we'll say X map equals I am read mask. That's a .bmp. And we also could have included the extension here, BMP. So now it's going to load those things into our workspace. image X. There it is in a certain color map, and then we can apply certain color maps to it here, like our black and white color map that came with it. It's a default map that gets saved with the file. So notice that when we saved the file, I am right, we didn't indicate any color map, and it saved the default map so that when we loaded it, it had this default map. And we could also say axis equal axis off and present it like this. So there we have it, a random noise mask that we've saved and loaded and presented. Let's try the same thing, but unindexed with this third dimension. So we'll have a color mask. So in this case, we'll say mask2 equals rand 400 by 3. And we have this third dimension. Let's clear off, close off. And we have this third dimension to represent the different color, the red, green, or blue. And now we'll write we'll call it mask2.jpg, and it is a JPEG. So now you see we've saved this mask2.jpg here, and if you in the preview you can see that it is what we want it to be, a color noise. So now we'll clear the workspace, and we'll say x equals imRead mask2.jpg. Now it's loaded it in, and we can say image x. Let's say axis off, axis equal. And now we see that it's colors. It's random colors at each location in the matrix. And we can try to add a color map to it, but nothing will happen because it already is using this variable x and the three dimensions of it. So if we say x, 1, 1, and everything, this is the first item in this top left pixel here. Has 226 red, 221 green, and 192 blue. So just to show you, we can go RGB color lookup. And you can pick different colors here on this kind of thing. So say we want this like red here. Then we can see that that red has this R, G, and B value. So you can look up, you can find colors that you want here and use those red, green, and blue values in Matlab to represent that color. So let's start in a new video this next exercise. So see you in the next video.